Hey everybody, welcome back. We're finally back to work on our outdoor wood boiler project. It's been a couple months since we released part 3 of the project. We had a goat barn project going on. We had to build a goat barn. Got some goats that were kidding here in January, and we had to have some cover for them. We'll show you that in another video. Go check out the goat barn video. But today we're working on getting the outdoor wood boiler connected to our floor for our hydronic floor heat. So I'll give you a shot and show you what's going on. So we've got all these fittings and stuff. We've got a heat exchanger, the thermostat control. We've got a whole potload of fittings. We've got gauges. These big flat boxes are manifolds. We've got pumps. All this I ordered from PEX Universe. It looks a little complicated, but I just tried to get everything I could from PEX Universe. They've got really good prices on fittings and stuff, so I tried to think of everything that I might need and ordered that. So what I'm going to do is I'm going to get all this stuff unboxed and spread out on the floor here and try to get a layout, what I plan on putting up on the wall here before I put it on there, so that I can maybe do this once and get it right. Where that's going to be going will be over here on this wall. So we've got our plywood up. That's where our PEX comes out of the floor, obviously. You can see our PEX that comes from the outdoor wood boiler. And then that's 3/4 inch plywood. So that gives me the freedom. I can put a screw anywhere. I can mount anything wherever I need to. So we don't have to worry about where components are getting mounted or anything. Before I do that, we do have some paneling that we're going to put up. This is going to be the laundry room, and we're going to try anyway for this to all be exposed. So we wanted to have a wall covering that was going to look pretty good. We're going to try and keep the aesthetics in mind as we do this as much as we can anyway. It's possible that we may end up having to put just cabinet doors over the entire thing to cover it up, but we're going to try to avoid that. So we're going to start with this and see how it goes. I'll show you kind of the process of how we get it laid out once I get everything figured out, and we'll walk through what it's going to be. Now I need to consult my hydraulic schematic that I drew up one day while I was at work on a Skype meeting. We'll see if we can decipher all this back again. Okay, I think we're there. I only ended up with a few extra fittings. I'll kind of walk through what's going on here, but it'll be a lot easier to see when we get it on the wall. So we'll start. Those are my 2 sets of temperature and pressure gauges for the water coming in from the stove. One thing I tried to do here is put plenty of gauges in. From history I've had working on hydraulic products and stuff, it's hard to tell what's going on in a hose or a pipe unless you've got a gauge there to tell you what's going on. And this being the first system I've ever designed, I imagine there's going to be some troubleshooting, so I'm going to need to know what's going on at each spot. But so we'll come in through those 2 T's with the 1/2 inch drop on those. We'll go down to these. I'm apparently missing a T for to do my temperature and pressure thing again the same way, and then 2 just ball valves. So what those are for is those are going to be the circuit that goes out to the driveway for ice melt at some point. For quite a while now, they're just going to be shut off. I don't even have the driveway poured, but I've got it plumbed up. Anyway, coming along, from the top temperature and pressure setup. We'll go all the way over to this plate heat exchanger. We're going to do that for the hot water heater. So hopefully we can have endless hot water. Above that is going to be the taco, however you pronounce it. I'm going to say taco. I like tacos. But anyway, so that's my zone control, my pump controls. And then we come down to each pump. So we'll come out of the heat exchanger, we'll go into this pump, and that pump. From those pumps we got isolation valves, pressure on the bottom side of each pump to see what we're getting out of them. Then we'll go into the supply side, then through our circuits, back up through the return, out this elbow, up through another pressure and temperature setup, which that's sitting next to that pump. That's not part of it. Temperature and pressure setup, and then we'll come up and tee into a return line at some point. The supply line, this is something that I learned setting up a chiller to cool a hydraulic tester at a previous job that I had. So after the supply side of all the pumps, or I guess it would be the inlet side of the pumps, the supply that we're getting from the outdoor wood boiler, I've got this gate valve and a check valve. So what that's going to be for is to create a pressure differential in that loop to make sure that we're supplying enough inlet pressure to all these pumps and that we've got a lower pressure to go on the return side. That'll make more sense hopefully as we get it all put together. But right now that's the setup. It's a little bit bigger than I expected, so we're going to have to do some squeezing to get everything lined up on the wall, but next we'll work on getting the wall ready and probably get these manifolds put in place. That's going to kind of dictate where everything goes, and start plumbing things up. Okay, after some work, we've got the wall ready. This is the paneling. We did it horizontal. It kind of looks like some, I don't know, shiplap or something like that. Just thought it was kind of a cool look. We've got the first manifold mounted. Looks like I'm gonna have to do something. I got some stainless screws to mount this with, just to make sure they don't rust or anything. And the screw heads are smaller than the mounting holes, so I've got it kind of hung there for now. The hardware store is closed, so tomorrow I'm gonna have to see if I can get some stainless washers or something to hold that on better. But anyway, we're gonna start terminating these circuit ends here. I'll show you how that works. It's not too complicated of a process. So basically, if this was your tube, there's three pieces that go on it. So once I cut that tube to length, I'll slide this nut on there. And then there's a ferrule that goes on there. And then this little O-ring adapter will slide in the end of it there. And then that all slides up and then just threads on to the bottom of each one of those fittings there. So we'll get to work on that, trying to get all these dead-ended. Since I got everything laid out on the floor, some of the stuff has changed a little bit, just oriented a little bit better, mostly for space, so I had enough room. So we'll get everything set up and get to work. Okay, quick update on progress here. We got all of our manifolds mounted. From the manifolds, I had to change a little bit from the layout that I had on the concrete floor over here as we got putting things together. Things had to kind of evolve. So, as you can see, I've pretty much used up about all the space I can on the wall here. So what I originally had was the inlet coming in on the left side here, and then this valve would have been over on this side, so the outlet coming out over here. Well, you can see how much room those take up. And so I decided I needed to take advantage of the fact that these are offset. The return is farther back than the supply. So I did both of them on one side. It's a little tight in here, but not too bad. I didn't have to force anything. One thing I was a little disappointed on was these valves. If you shut that valve, oh no, I can't even get it shut. I'll have to get something to shut that, or to open it, sorry. But whenever you go to shut those valves, they hit the walls pretty hard. So that return manifold is tilted out just a little bit in order to be able to shut that. So not too big a deal, but we got everything set up that way so everything comes out on the left hand side. So you can see we've got all of our returns tied together here, and they will go out there. I don't have anything hooked up. And then all of our supplies, we've got our zone pumps hooked together or hooked to the supply, and then across the top they're all tied together. We'll talk about a little bit more about what's going on up there. For mounting the pumps, this was something I was a little bit worried about, but I found something that worked pretty good. These are 3-inch just angle braces. I thought I had a package here, but they're just like corner braces for a shelf or a box or what have you. I bought them at the hardware store. All I had to do was drill the hole out to be a little bit bigger. I found them that had about the correct standoff, so we were able to just screw those on and run the bolts from the pump through there, and that's a pretty good mount. On this one over here, I ran out of room on the plywood. I'm there on the metal post. Well, I didn't want to have to weld anything there back against that post, and with the thickness of the paneling, it changed my height. So I went ahead and mounted just one above the other one. That one works pretty good. It could rock a little bit this way, I guess, but with all the pipes and everything there, it's pretty solid. So I've got more to go on the inlet and return and getting all this stuff connected. I've still got my heat exchanger. One thing I did forget earlier was my mixing valve, so I've got to get that and get it incorporated, and then we'll show you how we put everything together. Okay, we had a wardrobe change. It's the next day. I got my parts from the hardware store, so we can get back at it. So what I've got going here is the PEX coming through the wall was a 300 foot or 100 foot roll, I think. But anyway, it was on a roll, so it's got a bunch of memory, and it's curving up. For all of this, I bought the straight PEX pipe, like 5 foot lengths. I think it was about $5 a stick, about $1 a foot. Anyway, for all of this, that's crucial. I don't know. There's no other way you could do it. Trying to fight the stuff that was on the roll would be impossible. But anyway, so I've got a straight piece to go in here, but since this piece is curved up, I cut another part of that curved piece to try to curve it back down towards the wall. I don't know if it's going to be enough, but I think it'll be enough to just kind of help this joint anyway. It's not going to line up perfect, but we'll see what we can get out of it. looks like we need to start on the heat exchanger. Okay. So for mounting, this is, you're actually looking at the wall side. So I'm going to mount this as if I was looking at it. This will be up, this will be the bottom, and then our warm PEX line coming in this side. So again, on the mounting side, I found some more of these big angle braces. We're going to try and figure out what we need to do here. I'm going to mount it like that so that they're hidden. I'm just going to do some eyeball measurement here. This fitting, where it needs to connect up on the wall, needs to be about 2 3/8 of an inch from the wall. So, and actually, that stud is centered in these fittings. So, that should make it a little bit easier. If I make that 2 3/8, that's going to work out real close. So there's the last existing hole here. If I drill that out, go for that bolt, or go for that stud, that will put me very close to where I need it, and then I can just measure over for that one. So I'll get these drilled and we'll get this mounted up. As you can see, we've got the heat exchanger mounted up. I made a mistake somewhere in my measurements and ended up having to stick some spacers, see if I can show you here, between the L brackets and the wall to get spaced out to line up with this pipe correctly. So anyway, we got that corrected, taken care of, and then from there it was just coming out of the heat exchanger over and down to the first circulator. So that completes all of the plumbing, and we'll walk through that here in just a little bit. But the next task will be to wire up all of our circulators to our pump control. It's pretty straightforward. This is a four-zone pump control. It's a taco controller. So we'll have all of our thermostat wires come in up there. Everything's labeled nice, and then all of our circulators will connect neutral and hot here with our input from the breaker box here. So we'll get that put in. I've got the cover off one of the pumps here, and the only thing that they give you is a yellow and a white. I looked in the instructions, and from what it says, that it doesn't matter which way you hook these up, but commonly you do use the white on the common and on the neutral, and the yellow on the hot wire. I've got this 14-3 flex cord that I'm going to use. I think it'll make a pretty nice installation. It's weather tight and what have you. So we will hook that up, and then we're probably just going to hook up a thermostat to get things going today, but then I'll go through a video on the thermostat installation once I read up on what exactly has got to be connected here. Okay, this is our final product here inside the pump control relay. We've got all of the circulators wired up, got the wire stapled up nice and neat. They're connected down here to the zone, into each individual zone. Just the neutral and hot, and then the grounds I should have run all the way over to the left, but I got them in there on this other screw. They're tight, so it'll work, but it was kind of a pain to get them all shoved in there. This over here on the right, that's our power coming in. I ran that in from behind the wall just so it would be nice and neat. Up top, right now I've only got one thermostat wired up, and it's kind of temporary. I don't have the walls where most of my thermostats are going to mount, which will be also where the floor sensors go on the floor or in the floor. So I've just got this one set up to run it for now until I get all the framing done. The red and white wires, those correspond to the R and W also in the thermostat. And then I've got the blue wire hooked up from what I read in the instructions. That should power my backlit display so it doesn't rely on the batteries all the time. So we'll see how that goes and make sure I got that correct. But with that, that wraps up the installation of everything. Okay, now that we've got everything installed, I'll walk through how the theory on how all this is supposed to work. Hopefully it pans out that way. So we've got our hot water will come in from our outdoor wood boiler here. We've got just temperature and pressure gauge to see what we've got going on, and it'll come into this mixing valve. So what this mixing valve does is it controls and outputs a certain setting or temperature of water. So for instance, if I'm running my outdoor wood boiler at 180 degrees, I can set this to 140 degrees to not have such hot water going through my floor, but still be able to run my outdoor wood boiler where it's more efficient. We'll see how that goes. I'm going to play with some ideas. I can adjust the temperature on the boiler. I can adjust the temperature here, so we'll go back and forth and just see what works out best. But it takes this hot water in, and we'll mix cold water with it to make whatever temperature of output water that I need. So we'll have hot water coming out through here. We'll ignore this for the moment. We'll come through here, go into the heat exchanger, and then back out. The heat exchanger, I will plumb a potable water connection in here and then out there. And what that will do is it will heat my incoming water as it goes into my hot water heater. So for right now, we'll just use the one side of it. It'll get warm and it won't do anything for as far as not being hooked up. But next, we come out of the heat exchanger and down to our supply loop for our pumps. So basically, the water's just coming through, and we've got water supplied to the inlet side of each pump. Then it comes to this control valve. So assuming all of our pumps are off, our water is coming in, making a loop, and it'll be coming back this direction. So with this, I can control the pressure differential for the pumps. So if this is wide open, basically the water will just go through, pump back through, and go back out to the wood boiler as the cold return water. The reason for this is if I'm pumping water out and then the return water's got to come back in here, I want to make sure that I'm supplying an adequate amount of pressure to the inlet of my pumps. So by cranking this down, as water's moving through, that'll create a restriction and make a higher pressure on this side than on this side. So that will make sure, since the water takes the path of least resistance, it won't just want to go back through the loop, it'll force it down through these pumps. So this will be something that I'll have to adjust and play with as well. Here also is a check valve. I'll explain that here in a second. But then this is our cool water return that goes back out to be heated again. So that's what happens if none of the pumps are on. If a pump is on, then our water's going through again. Say zone 3 calls for heat. This pump will kick on and we'll pump water down through. This is a bad example. I should go over to zone 1. Zone 1 kicks on, calls for heat. This pump kicks on. It starts pulling water from our feed loop and goes down into the supply side of our PEX manifold. From here, the water splits evenly into all 4 circuits. It'll go down through this pipe, out through the concrete floor, back, and come in on this one. As it comes through here, then it all comes back together, goes on this blue return loop, as it goes back up. So back to this valve, if I'm pumping water through, it goes down through the floor, comes back, and then we're pumping it this way, I need to make sure that it goes back out to the outdoor wood boiler and not come back here and just make a continuous loop. So this is a check valve. Basically, it only allows flow one way. So flow can go through that way, but if anything comes to go back through this way, that valve closes and won't let it do it. So that's the reason for that there. On each one of these manifolds, which is pretty standard, these are all little flow meters, so I can balance this to make sure I've got an even amount of water going through each circuit, and that's controlled over here. We've got air bleeds, stuff I can hook up hoses for. That's my pump control relay, so anytime a circuit or a thermostat calls for heat, it sends a message here, it switches each individual pump on depending upon which one needs heat. The other thing over here on this side, these small lines that are teed into the supply and return loop, you can see. This is a separate circuit. Where these go is out to my driveway, so I didn't figure I needed a whole separate zone circulator or pump, and I figured I could just, that would be a special occasion. I could come and turn these valves, adjust them to what I think is about right, and then to warm up the driveway for snow melt. So, and then just plumb them back in so that we can go return. And that's the basic operation. It looks a lot more complicated than it actually is. The mixing valve complicates things quite a bit. These manifolds look complicated. Also with that, you can see that I don't have my manifolds all tied up real nice and tight. I've got stuff running all over the place. That's because I made a pretty bad mistake in the previous video when we were testing things out to see which circuit belonged to which zone. I ran water through those and I never cleaned it out. So got busy working on the goat barn project out there. Never got back around in here to work on this or mess with it. Kind of forgot about it. It froze, and I've got busted circuits in the concrete floor. I know I've got at least one that leaks, and I've got two others that I'm not sure about. So for right now, I just put loops on these manifolds to try so that I can fire it up and test everything out, keep that from happening again. So we're going to do a separate video on trying to repair those circuits if we can. I've got an idea. We're going to try it. Some people have had success with it. If that doesn't work, then ultimately the repair is to chip up the concrete and replace the pipe. So we'll see what happens there, but we'll have that in a future video. So if you like what you see, like and subscribe. Thanks for watching.